Oh, 80. Oh no, you're doing, that wasn't that one. That was this one. That's this one down here. So the first one was 240, the second one was 80. The next one has to do with solving distance, rate, and time problems. We know that rate times time equals distance. Right? If we go 50 miles an hour for 3 hours, we got 150 miles. So on these first ones here, we're going to have things where we're either going against the wind and with the wind, or upstream and downstream, where something's pushing against us, making us go faster or slower. So our rate is going to have two different things. A cyclist travels 22 miles in 2 hours going against the wind. She travels 42 miles with the wind in the same amount of time. What is the rate of the cyclist in still air? What is the rate of the wind? So we have two different things. We have the rate of the cyclist and the rate of the wind. I'm just going to use a C and a W to keep track of which is which. If I am going against the wind is going to blow against me and slow me down, right? It's harder to ride my bike into the wind. So my overall rate is going to be the cyclist minus the wind if I'm going against the wind. That's my rate. Times my time. My time here is 2 hours to equal the 22 miles. Now what they're going to do with that equation is they're going to go ahead and divide by that 2 right away to get the C minus W by itself. So they're going to go ahead and divide by 2 and say that C minus W then equals 11. Then they're going to do their second equation. She travels 42 miles with the wind in the same amount of time. If I'm going with the wind is pushing against my back. In theory, it's going to make me go faster. So my overall rate is going to be C plus W, because the wind is going to speed me up. Same amount of time, so I'm still going to go 2 hours, but this time I went 42 miles altogether. Again, they're going to go ahead and divide right away to get the variable by itself, so we're going to divide by the 2 and say that C plus W equals 21. Now that kind of looks like that problem where we had the sum of two numbers is and the difference of two numbers is, right? We have opposites in front of our W's, so we can just go ahead and add to eliminate the W's from our equations. C plus C is 2 C's. Negative W and a plus W cancel out. 11 plus 21 is 32. In order to solve that for C, all we have to do is divide. C is going to equal 16. So the rate of the cyclist, 16 miles an hour. We again need to find the rate of the wind. Personally, I think it's easiest to put it in with the plus 1. We did the one with the minus before. If I do the plus 1, I would say 16 plus W equals 21, plugging it into that second equation. And all I need to do to solve that is subtract, right? So 21 minus 16 gives me 5, right? So the wind is going 5 miles an hour. So number 8 is going to look really similar to number 7 here. A motorboat takes 4 hours to travel 192 kilometers going upstream. The return trip takes 2 hours going downstream. What is the rate of the boat in still water? What is the rate of the current? So I'm going to use B for boat, C for current. Use something that makes sense to you so you know which answer goes where. The motorboat takes 4 hours to travel 192 kilometers going upstream. So if I'm going upstream, am I going to go faster or slower? Slower, because it's harder to go uphill, right? So my overall rate is going to be B minus C, the boat minus the current. The time on that one is 4 hours. The distance is
192.
192 kilometers. So my rate times my time equals my distance. Again, they're going to go ahead and divide by that 4 right away. So if you go ahead and divide that by 4 for me, B minus C is going to equal
48.
48. My second equation on my return trip takes me 2 hours going downstream. So if I'm going downstream, am I going to go faster or slower? I'm going to add because I'm going faster, right? In theory, if I go downhill, I should be going faster than if I'm going uphill. This time my time is 2 hours and my distance is
The same.
the same. Whoops, my card got full. Nope, I'm still recording. That's your phone. I thought that was this thing. It makes music at me if I run out of space. So again, they're going to go ahead and divide by that 2 right away. So that B plus C is going to equal 96. So again, now I have one difference and one sum. I can just go ahead and add those together. If I add my 2 equations together, I'm going to get
2b equals 144.
2B equals what?
144.
144. And if I divide by 2,
72.
the boat is going 72. 72 kilometers per hour. If I want to find how fast the current is going, where might I plug that in?
And B.
In for B, do we want to use the top equation or the bottom equation?
The top one.
The top one? Okay, we'll use the top one this time. So we would say 72 minus C equals 48. If I'm going to solve that, I would first
Subtract the 72.
subtract the 72. So negative C is going to equal
24.
negative,
24.
negative 24. Then I end up having to divide by negative 1. So C equals positive 24. So the boat is going 72 kilometers per hour, the current 24 kilometers per hour. Now, the next ones are still using that rate times time equals distance, but now they're not going to be going against and with something, and they mix these 2 kinds of problems together. I don't know why, but they did. But what we want to think about is what's happening here. 2 buses leave towns 228 miles apart at the same time and travel toward each other. One bus travels 16 miles an hour faster than the other. If they meet in 2 hours, what is the rate of each bus? I like to draw pictures. 2 trains leave towns 228 miles apart at the same time, and they're traveling toward each other. So one's going this way, one's going this way. I know the whole distance is 228. So if I'm going to find the distance of each person or each bus, I need the rate and the time of each of those. So it says one travels 16 miles an hour faster than the other. So I'm going to call the rate of one of them R, because I don't know it. How would I write the rate of the other one to show that it's going 16 miles an hour faster?
Multiply. All right.
Faster. So I'm doing 16 miles an hour faster than the other one.
Add.
I'm going to add the 16. So one of them's rate is R, the other one's rate is R plus 16. Now, we have a faster bus and the slower bus. The faster one is obviously the one with the plus 16, right? So this one's rate is R plus 16, and this one's just the plain R. The time, they both meet in 2 hours. That means one went for 2 hours and the other one went for 2 hours. So this one is going to go for 2 hours at R plus 16, and this one's going to go for 2 hours at the rate of R. Rate times time equals their distances. If I add the 2 distances together, I should get the 228 miles that they are apart, right? So 2 times r plus 16 plus 2r is going to equal 228. And now I have my equation. And I got to go through all the work of solving that. So using my distributive property, 2r plus 2 times 16 would be 32, plus 2r equals 228. Combining my like terms, 2r plus another 2r would be 4r, plus 32 equals 228. To solve that, I got to minus my 32. I'm going to let you do that for me. What was that? 196? 4r equals 196. If you get a different number, holler. What? And if you divide by 4, she's just way ahead of me. 49, you said? So, this one is going to be going 49 because that rate was just the plain r, right? The slower one. The other one is going to go r plus 16. So we're going to have to take 49 plus 16. And 49 plus 16 would give me 65. So that bus is going 65 miles an hour. The other bus is going 49 miles an hour. I better talk really fast. I got behind when I had that messed up problem. 2 buses leave the station at the same time and travel in opposite directions. So, one's going this way, one's going that way. One bus travels 12 kilometers slower than the other. If the 2 buses are 654 kilometers apart after 3 hours, what is the rate of each bus? So again, we know that they're 654 miles apart. We want to write something to represent their rates. One of them we're just going to call R, and the other one would be what?
R minus 12.
R minus 12, because it's going 12 kilometers per hour slower, right? R minus 12. Now, obviously, the slower one is the one with the subtraction, and so the faster one's going to be your plain R. So, they're both going to go for 3 hours, so I'm going to take 3 times R minus 12, and then the other one is just going to be 3 times R. We know if we add their 2 distances together, we should have the total distance of 654. So 3 times R minus 12 plus 3R equals 654. Using my distributive property, 3R minus 36 plus 3R equals 654 then. Combining my like terms, 3R plus 3R would be 6Rs. 6R minus 36 equals 654. I got to move my 36 to the other side, so I've got to add it this time, right? It's a minus 36, I got to make it a plus 36. So 6R is going to equal 690, thank you. And dividing by 6, R equals
115.
115?
Yeah.
115?
Yeah.
So that is going to be the rate of the faster bus. Holy cow, he's going fast, 115. The rate of the slower bus then, I'm going to subtract 12 from that. Oh, that's supposed to be kilometers per hour. That's why it looks really fast. I was going to say, if he's going 115 miles an hour, that's really fast. But kilometers per hour would make more sense. It said kilometers up there. R minus 12, so 115 minus 12 would be 103. All right, we're going to save the other ones for Wednesday because we only have 1 homework page to do on Wednesday. So we'll finish this up Wednesday and then do the next homework page. And we'll have all of Chapter 3 done. And I got to figure out what that other problem was supposed to be.